Okay, so this is part two of the venner autowailer video which I uploaded previously. So you'll see it on the last video upload if you want to go back and watch that first. And what we were doing, we were testing this new yellow autowailer that I've just picked up. So this is a later Cold War model. You'll notice the ones who have watched that video, this board has changed slightly. The grey one's been taken off now and that's been replaced with an old MEM three-phase contactor, and that's to get this one ready for testing on big three-phase sirens. So that will be a future job to do there. But the problem we had with this autowailer was the timing motor wasn't cutting out at the end of the signal phase. And I'm happy to say I have managed to fix that. It probably was one of the easiest fixes that it could have been, which was a bit of luck. But what I thought today is we'll actually go through the mechanism and what each of the parts are in there, just to show you. And we'll do a couple of runs just to show you it fully functioning properly now. So as we said before, this is a fully self-timing autowailer. So this one here, whichever signal you press, you don't have to hold the button down like you did on the older grey ones to keep your signal running. You just press the button once, the button will drop down and that will be held captive by the unit, and it will run the entire signal for 1 minute before resetting itself and shutting down. And you also have this little cancel knob in the middle here, so if you press the wrong signal you can cancel that signal out before the 1 minute is up. Now the problem we had before, the timing for the signals was working fine, but after the 1 minute the timer unit was continuously running, resetting itself and just running again continuously, so it wasn't ever stopping. And we have now managed to fix that. But what I thought we would do first, before I show you how I did the fix, was we'll take this mechanism out and we can actually see how this unit operates, because it's much more complicated than the earlier grey ones, because it does have the extra timing mechanism stacked on top of the attack red timer. So I've just dropped the time carriage out of it for the moment. All we have to do is basically push these two little clips here over and it just pops out off of the carriage there. And much like the earlier grey autowailer, you can see the pin slot holes here for the electrical connections, and they are actually on the back of the unit here, so it just plugs straight in and can come out quite easily. And that does the electrical connections between the timer unit itself and the forward contactor block here, and obviously where our incoming cables come in just down the bottom there. So on the actual block here, this is our attack red side and this is our attack white side. And when we press the red, what we will see is actually down on the back for the red, so I'll just quickly flip that over. What we'll see on the back of the contact block there is as that red's pushed, you can see the actual contacts moving there, and it's actually disconnecting from the top circuit there and reconnecting to a lower circuit down there. So it's disconnecting the attack white side power and powering the attack red side down there. And then on the white side, that operates down the front side here. So we'll do that and you'll just see a similar set here where it disconnects from one contact and reconnects to the next. So in order to figure out what was going wrong with this autowailer, the first thing we need to do is understand how it works. So it's a bit of investigation to see exactly what is driving what on this. So this is one of the side views of the carriage itself, and we've got quite a good view of some of the different mechanisms. And unlike the earlier grey autowailer where the motor was only powered to do the attack red timing, this one needs to be powered to do the red and the white signal. So it needs to have power running to turn that 1 minute signal timer at the top, even for the white signal. So this one obviously is a lot more complicated drive mechanism. Now the coil motor itself is in this lower Bakelite unit here. We don't need to take that apart today, but if you do want to see inside one of them, in one of my earlier venner autowailer videos, we actually take one apart to replace a broken coil inside, so you can see it in that video. But first thing we need to work out is how the drive mechanism from the motor works and which cogs are running which parts of the signal. So as we can see, we can quickly look at the wiring diagram that comes inside the connection of the unit, just to give us an idea of exactly what we've got going on in this unit. So as we can see, we've got our switches marked at the top here. So there's our alert side, the attack red, and the raiders past white on this side. The symbol on this side is our coil, and we can see one end goes directly to the main neutral connection down the bottom there, and the live is fed from the other side. And we've got 3 cams there, so we've got one marked as top cam, one marked as bottom cam, and then we've got a third one which isn't named at all, and each one of them is a set of contacts on each of the cams, so each of them is doing a function, and that's what we need to figure out on the actual unit itself, so we can work out what's going on with this one. So that just gives us a bit of a idea of how many contacts we've got sitting in there, and that's what we're going to need to figure out now. So as we said, the first thing we need to do is work out where the drive is initially coming in from the motor, which is driving everything else. So if we just zoom in slightly on this, gives us a bit more of a close-up, and if we spin round, we can just see actually the first main drive wheel, and it's just, I'll go in my tiny screwdriver, it's just this wheel at the bottom here with the grooves on, you can see there, which is below this set of contacts here. That's our initial drive main wheel, and it's actually been driven by a tiny little sprocket which comes up from the motor compartment just inside this metal unit in the background here. The front of it is actually open and there's a tiny sprocket poking out, and that will drive that lower wheel first. So that's where the initial power comes in, and that also drives out onto this side mechanism here. And what we can actually see here, we've got the main drive at the bottom here, but just in between you can just see this black sprocket just here, and that's actually a reversal gear. So when this one is turning in this direction, the upper half will actually be turning in the opposite direction. So the bottom 2 cams turn one way, the top cam actually turns another way. So that's done through that side unit there, and we can just see the much larger upper drive wheel just at the top here, and that's doing our 1-minute signal timing, and that's the one which isn't disengaging when it was supposed to. So before we move up to looking at the top section where we've got the issue, first of all we'll just look at what that lower drive wheel is doing before it goes up this reversal side just here. So the lower wheel, where the power initially comes, runs these 2 lower cams here. So we've got the first one at the top here, and we've got a lower one down here. Now this one with a set of contacts actually sitting on it here, we can tell is the attack red warning timer. Now the reason we can tell that, we can see one of the cutout slots just in it there, and there's 3 of those running round this wheel, and it's got a much larger cutout in it there, and that's actually the 3 seconds off. So as that's turning, at the minute the contacts are pushed together because they're on the outer part just here, but when it moves into that groove there, the contacts actually separate. So as that's spinning, it will just constantly be doing 5 on 3 off for the attack red warning, which is a little bit of a mystery as well, because the venner autowailers were all set up to do 5 on 3 off for the attack red, whereas the remote control system which ran them, which was a normal way of operating them, actually ran on 4 seconds on 4 seconds off. So there was a slight different time difference between this local test unit and the main remote control unit, and there's never really been a reason behind that. But below that we've got this lower cam wheel here, which is also driven at the same time, and we can just see one of the cutouts just in a corner of it there. It's a much smaller cutout just by my screwdriver, and there's 4 of those on that wheel, and that must be about ½ a second disengagement time, and that's actually connected to this set of contacts we can just see here. Now I've managed to get this unit working, as I said, but I haven't actually figured out what this lowest wheel is actually for, because even when this set of contacts here is disengaging, that we can see just here, even when that's disengaging, the motor isn't being depowered. So I haven't figured that one out yet. That's still a bit of a mystery in this one, but for what we're doing here today, it doesn't seem to make any difference to us. If we move back round to this side, then we'll zoom out slightly on it here so we can see a bit more of the mechanism. So as this drive is driven up, we then reverse to this upper set here. Now on this unit here, this is actually the drive where my screwdriver is, that lower set of cogs, and that's actually what's driving this lower wheel just here, which is our timing wheel. The cog just above it here is actually a latch release mechanism, and I'll show you that when we look from the top. But as far as we can tell, we can see on the bottom half of this motor there's two contacts. There's this one here, which is our mystery one, and then we've got our attack red one just on the inside there. But there is the third contact set here, and that is this frontal contact just here. So we'll point with the screwdriver, just this set of contacts here. Now this is a set of contacts I think was giving us a problem. So if we look at the actual unit from the face, we can see it just down here. Now when I push this mechanism apart here, it actually lifts them contacts out, and when tested that actually disengaged our top timing motor, and this was the one which wasn't disengaging. So what was happening, this was continuously running, hitting its endpoint, resetting, and then continuously running again because this contact down here wasn't separating. So what we do, we'll just have a look at what's going on the top, because most of that unit is run from the top. Okay, this part's going to be a little bit harder to film, so you'll just have to bear with me. I'll zoom in and try and keep the camera as steady as possible. So this is the top half of the mechanism, and all the wheels up here are to do with the 1 minute signal timing. So when the buttons are depressed, this is a part of it which makes that time signal time lasts 1 minute and then automatically disengage at the end of it. So this was the part that was causing us the problems, and as we can see, we've got the top of the reversal mechanism just on the right hand side here, just where my screwdriver is slowly sneaking in there. So the bottom cogs on that, which are the ones just in here, they're the ones which are driving our wheel just here. And curiously, this top wheel is actually made of Bakelite, where everything else is metal. One of the only reasons maybe this is a sacrificial gear, so if the mechanism jams, this would be the one that would break, probably because it's the easiest one to get to out of all the mechanism. Maybe, possibly, that's just my thoughts on the matter. And this is our ratchet unit just here, which I'll explain in a minute. And this is the top face of the upper timing unit just here. So what we'll do, first of all, we'll spin round and we'll just show you there are a couple of important pins on this one, which help us locate what everything's doing. So just down the back here, we can see a pin on the top of the frame here, and that's matched to a pin on the lower timing wheel just here. Now at the moment that's in their start position, so when it winds itself back, those two pins make contact, and that's where it stops the wind back. And the wind back is actually done. You can just see inside there is a coil spring, and as this unit is being turned and powered, that coil spring's getting tighter and tighter and building up power, and when the ratchet mechanism releases it, that's what makes the whole mechanism return to reset. So this is in its starting position as if it had been reset at the moment. So these two pins here are making contact. Now I did mention about this before, it is set for 1 minute running. You can see two other time holes in there of 48 seconds and 40 seconds, and that's so you can change this pin here to make the run time less. Now I thought it would just be as simple as changing that pin over, but I think it would actually be a bit more complicated than that, because there is one other important pin, and that is on this lower Bakelite wheel, and we could see it just in the very bottom there. Now this pin at the minute is set for the 1 minute position, so if you change them top pins, I believe you'd have to take this mechanism apart and reset this wheel to a different position in order for this to continue working on a shorter cycle. So each of these pins has an important job to do. So we can see the top pin, which is in its restart position there, being held by the frame pin, but there's also another one of those which continues through the lower face of that wheel as well. So there's two pins there, and we've got the pin on the Bakelite wheel at the bottom there, and each of these three pins has a separate job to do, and they actually involve the metal bars at the front of the mechanism. So we'll pop round to there and have a look at those. So as this timing wheel slowly turns round and it gets near the end of the 1 minute signal, these pins each have a separate job to do. Now the two pins which are in this top face wheel, the one that's at the top here and the one that pokes through the bottom, are actually our signal disengaging pins. So the one at the top will activate this arm here, so if it's the attack white that's been pressed, it will disengage by moving this lever over, and the button, which is spring loaded on the front contacts, will jump up and lock this in place beside it, so then that way the signal can't be activated again. The lower wheel on that will do the attack red side, which is this side here. We can just see that bar moving underneath. Now the one that was on the Bakelite wheel is for the ratchet release. Now we can see that running through the unit here. So it's this lower bar just here, and we can see it runs through a pivot and then carries on up to the wheel up on this side. Now we can actually activate that manually via this rod here. Now the signal cutout, which is that little twisting lever on the top, actually engages this lever here, and we can see it pulls this third bar. At the same time, it also pulls both signal bars at the same time, and we can also see it releasing the ratchet on the cog just at the top there, and that would allow the built-up tension from the coil spring inside here to rewind the unit back. And we could just see where that coil spring actually attaches is just onto this bar at the back here. We can see the start of that coil going into the wheel there, so that's where it's anchored to. Now interestingly, what we did find out was this bar also is a bar which opens that lower set of contacts just below the two springs there. You can see it pulling apart when that bar is activated, and that actually disengages the power to the motor completely and stops the unit from turning. So this is part of the mechanism which was actually giving us the trouble. So we've popped it back in just so we could show you where the fault was found, as it's a bit easier with the mechanism in place. So we know the fault, after tracing where all the power comes from and how everything runs, was on this lower set of contactors just down here below these springs, and that was moved by this pivot bar here. So on the lower side of this here, there's a little rubber a pin which pokes out the bottom, which actually opens that set of contacts as the pin comes around and moves these bars over. Now the reason that these contacts weren't opening, because they were in actual fact being held back. And now if I press the attack white side, what you will see is the attack white bar at the top moves over and actually pushes this bar itself here, which is holding the contacts together. And when that is released, that bar moves back out the way, allowing this pivot bar to move over and open them contacts. Well, the simplest of things, where the bar bent and came down just in this position, it was actually bent over at an angle, so it wasn't in a straight position, and it was actually holding the bar continuously over here, more like it as if it was in the on position, somewhere in between, which was allowing these contacts to be permanently held shut down here, which was continuously driving that timer motor to go round. So we're just straightening that simple bit of bar which came down the bottom here. It allows this to move over and those contacts to go into the open position and stay open. So now when it's disengaged, the motor itself shuts down. So we can have a look at that mechanism running as it should do. So the eagle-eyed amongst you might have spotted in that last small bit of footage, it actually showed us what this lower mystery cam is doing. So I thought in the edit I'd add this in, as we think we have it sussed now. So the front contacts just here, which were the ones that were giving us the problem, that's the main power to the motor, but the motor is also fed from this set of contacts on this lower mystery cam. And as we can see in that short bit of video there, the motor did run on for a short amount of time after the main contact at the front disengaged until it reached one of the cutout points on the lower cam, which we can just see the front of the contact has dropped inside the Bakelite cam there. So as soon as it drops into the cutoff on the bottom cam as well, that finally allows the motor to shut down. Now I think the reason behind this is it allows the motor to go back to a reset position ready for its next activation. So if it lands on any of these 4 small cutouts which are in this lower wheel, which we can just see one just there on that lowest wheel there, that will finally disengage the power to the motor. So I believe this lower cam is just to get everything back in the right place for when it's activated again. Okay, so we're just going to activate the attack red with a screwdriver just so we can see the mechanism going inside, and we're just going to see if it actually cuts out at the end of its run. And there we go. So the button has pushed back out. We can see the real reset back to start of the 1 minute run, and the motor is now disconnected. So that's now fully operational on that side. So for the next test, I'm just going to activate the attack white side, and then we're going to just test the signal cutout after about halfway through its runtime, just to see if it's resetting on that as well. And what we'll do there, we'll just open the box up. We've turned it off. So we can see it's disconnected from the bar here. That contact has also opened up, and we're back at the start on the timing wheel there as well.